So hey guys, we are back with another video, and in this video we have got the KIMI K2 Tech Report finally. I think DeepSeek, right, when they released their model V3 and R1, they were ready with the reports, and that is the reason the whole the model ecosystem space got so much attention for that model, because the report was there. People could understand, okay, they have applied these tactics to improve their performance, and everybody was interested in replicating that, right? But KIMI K2, right? KIMI K2, they released the model 1 week back, and they mentioned the report coming soon, and they released that report I think 1 week later. So yeah, now when you look at the authors of this report, you will find the KIMI K2 as one of the author, KIMI K2, right? So they used the help of model itself to write its own report, and it's really fantastic. Now let's look at that. It's a mixture of experts, large language model. Everybody was expecting this. Mixture started it 2 years back, and we are here. I think Gemini 2.5 Pro, Claude 4 Sonnet, GPT 4.1, all the big LLMs we are seeing, all of them are using this mixture of expert architecture for long. So they have also used this Muon clip optimizer, right? I think I have been talking about this Muon clip optimizer in the last video also. They mentioned it I think 6 months back, and then they released a paper that it is even scalable to bigger models, and now they have implemented it. Okay, now let's look at the result. So the same thing, it's a 1.04 trillion parameter model, a 1 trillion open source model on Hugging Face. The number of downloads was around 200. I don't know who are those lucky 200 people who have the GPU access of downloading this model and testing with, because 1 trillion parameter model, oh my god. Now, they present three big things. The Muon clip, which we already have discussed, and we can discuss it here also. Second is large-scale agentic synthetic data synthesis data pipeline, right? Third is general reinforcement learning framework that combines RLVR with a self-critique rubric reward mechanism. Okay, now for understanding these specific topics, I can make specific videos which will help you understand the whole topic itself. Let's say for Muon clip, I am thinking to make a video next, so that I can give dedicated 15 to 20 minutes for this particular topic. Okay, so they have used this optimizer in different models before in testing in small models, and they said that they were seeing improvement in the results. Then they tested it on bigger models, 7 billion 13 billion models, and they saw results improving even better, and that is the reason they decided to go with this clipping technique. Okay, I think one of my colleague, right, who was working with me, they released that Z clip paper, right, which was actually also helping remove those spikes in the loss graph, right, during pre-training. So yeah, that is one thing I think a lot of people are working on nowadays. I remember Z clip being one of the top papers in the trending page of Hugging Face, and so will be this paper, because this Muon clip, right, it is going to help people a lot. Now, if you look at the pre-training loss curve, right, you will see without smoothing or loss sampling, it shows no spike throughout the entire training process. It's beautiful, isn't it? They have trained on more than 15 trillion tokens. Okay, more than 15 trillion tokens. And just look at the loss, there is no major spike. I see a small spike here, but it's fine, it's very small. Similarly, if you see here, during a mid-scaling tree run, attention logits rapidly exceeded 1000, which could lead to potential numeric instabilities and even training divergence. Okay. Now, if you look at this whole thing, right, the understanding of how they came to this procedure of using Muon optimizer, you will realize that this isn't made specifically for this model. They first were trying an optimizer base, like making an optimizer better, the algorithmic thing better, and then they implemented it on small models, then large medium-sized models, and then they decided, okay, that this model, this optimizer is good enough to be used in bigger models. So they decided to go with bigger models. Yeah, cool. Yeah. So let's look here. Mathematics data rephrasing, they are saying that this is the whole data set that they are knowledge data they are talking about. Style and perspective diverse prompting, chunk-wise auto-regression generation, fidelity verification. So to ensure consistency between original and rewritten content, we perform fidelity checks that compare the semantic alignment of each rephrase passage with its source. Okay, cool. So I think the model architecture is pretty much clear. They used in DeepSeek, they have 61 layers. They have also used 61. total parameters 1.4 trillion, that is 54% increase than the DeepSeek, which was 671 billion. Now, active parameters is even less. DeepSeek had 37 billion active parameters. They have only 32.6. Only 32.6. So big thing. Experts total they have DeepSeek at 256. They have 384. Now, in DeepSeek, right, they came up with the spatial this mixture of experts. They tweaked the whole thing and even increased the number of experts, and that helped them a lot. I think they have followed their tactics. And experts active per token is 8. Shared experts is still 1. Attention at 64 instead of 128 in DeepSeek, and number of dense layer is still 1. Okay. Now expert grouping is not done here, so yeah, that is one thing. I think we have discussed about the expert grouping and everything in the DeepSeek detailed video. I will pin that. You guys can go and watch that to understand the concept. Now DeepSeek sets the number of attention to roughly twice the number of model layers to utilize better memory bandwidth. However, as the context length increases, doubling the number of attention heads leads to significant inference overhead, reducing efficiency at longer sequence. Correct, they are right here, and for that I think they have figured out this whole thing. For example, with a sequence length of this, the number of increasing from 64 to 128 while keeping account to 384 leads to an increase of 83% increase in inference flops. Okay, think things are pretty clear till there. I think we can move to the post-training part, right? Post-training apps, they have done supervised fine-tuning as we were expecting. Large-scale agentic data synthesis for tool learning. So I think agents, right? The buzzword in the industry right now. Everybody is trying to become the best model for agentic use cases. And why won't they? Because the industry right now is shifting towards more the automated use cases, and agents are playing a vital role there. And so do the techniques will keep changing. So I'll leave this part to you guys because I won't be keeping the video long, but I'll make dedicated video to these specific things, just like I made for DeepSeek R1. Okay. Now reinforcement learning, I think they use this. They told about this verifiable reward gym, right, in the abstract also, that how they're using to increase that. Now let's look at the main part, the results, right? If you look at the results, the post-training evaluations, right, they have benchmarked all the top benchmarks right now. So here, now they have presented this in a smart way. All the open source models, KIMI K2, DeepSeek V3, Qwen 3, all are Chinese-owned companies. Proprietary models: Claude 400, Claude Opus 4, GPT 4.1, Gemini 2.5, Flash, not Pro, Flash. I don't know why they did that. Are all US-based companies. I wanted them to benchmark Gemini 2.5 Pro. Maybe they did not do that because of its thinking capabilities, same as they did for Sonnet 4 not thinking, and O4 Mini. Now, these are all non-thinking models, guys. If you look at the results here, you can easily see KIMI K2 Instruct is, I think, on almost all the benchmarks except 1 or 2 is outperforming all the other models. In live code bench 53.7, far ahead of any other model. Now DeepSeek V3 we can say, right, it is a 670 billion parameter model, but all these models are definitely bigger than 1 trillion. I can say for sure, right? Now considering that Moon Optimizer is helping them here, and the agentic use cases, if you see, I think tool use tasks, right, you will see here also the way they have trained the whole thing, the using of the data synthesis that they have done is helping them a lot here, right? Now here if you see the performance comparison of KIMI K2 against leading open source models across drivers, in open source I think it's the best model right now in the market, no matter what everyone says. 32 billion parameters are only activated, less than DeepSeek V3. So if anyone, right, they have the capability to run 37 billion activated parameter model on their GPUs, they can run KIMI K2 on that, right? So it's a good thing. Now safety instruction evaluation, who cares nowadays, but okay, we'll see. In interactive jail, I remember this benchmark from the Mixtel paper 2 years back. They introduced this thing, but I think no one was caring that time, and no one cares even right now. Now looking at prompt injection, iterative jailbreak, and I think Crescendo, right? These were the three. Okay, cool. So looking at the instructions, right, KIMI K2 instruct, right, it is performing better than all the other models. If you say it is even attaining the result of 100 on base 64. So I'm not sure about all these benchmarks for this one. You guys can read about it, the way they have introduced them in the paper. I'm leaving this to you. And if you look at the references and the ones, right, conclusions, we introduce KIMI K2, a 1 trillion parameter model, MOE model, leveraging the token efficient Muon optimizer and 15.5 trillion high token dataset. These two things together, working together, 15.5 trillion token high quality dataset with Muon clip or optimizer is making the whole magic work. KIMI K2 achieves stable, scalable pre-training, post-training, combines large-scale synthetic tool use data with unified RL framework using both verifiable rewards and self-critiquing feedbacks. I think RL is changing the whole game. RL, everybody has been working on it. I think once we got introduced to DeepSeek R1 and V3 with GRPO, right, everybody knew, right, that RL is going to play a very important role in the coming days in the post-training part, because 2025 is all about post-training, no pre-training, right? Cool. I think when you look at the others, you will see KIMI K2 as one of the other here. Interesting, right? The model itself helped the authors writing this whole paper. So sounds good. They have cited around 91 papers. So yeah, you guys can go and check them out wherever you feel that it's relevant. And I'll make a specific video understanding the specific part, let's say RL algorithm or the Muon optimizer for sure. I'll make a video so that the purpose of this video was to show you guys this technical report and see the results which they have presented in the paper, and the main three things that they are focusing on: the data synthesis part they have done for agents, 15.5 trillion high quality data set, and the third was Muon optimizer, right? So yeah, these are the three game changers in the whole thing. So the best open source model in the market is right now, as you can see, KIMI K2. So yeah, so thank you for watching the video, guys. I'll see you in the next one. Thank you and have a nice day.